So this one is an exercise which is related to mass spectrometer and the ionization energy. The first 12 questions I have already discussed, so I will start discussion with question 13 and I'll share the recording at the last for the first 12 questions. So starting with question 13. This question is about the bonding structure and properties of elements in period 3 of a periodic table. A student plotted a graph to show melting temperatures of the elements in period 3. So this is about the melting point. This is the same thing we just discussed now. As you can see, sodium, magnesium, this is a graph for a melting temperature is given. A student incorrectly plotted two values, one for metal and one for non-metal. Identify these elements. So which value student plotted wrong? Because as we discussed, when we move, like example, we have sodium, we have magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. So these are the elements which we have. When we move for first four elements, when we move across the period, what will happen? The melting point increases. And why the melting point increases as we move across? Because the first three elements have a metallic bonding, and metallic bonding gets stronger as we move across the period. And the fourth element in this series is silicon, and silicon belongs to group 4, so it is having a giant structure. So first, which one is wrong? Because it should increase this silicon, but aluminium is given wrong, because aluminium should be above somewhat here. Because as we move across, the melting point should increase. But here, the melting point is not increasing. What is happening? The melting point is decreasing for aluminium. So aluminium position is wrong. Then which other non-metal it is wrong when you check? So because they have a simple molecular structure, so simple molecular structure, what should happen? The force of attraction between them is weaker. So the melting point should decrease. So it should not be higher. It should be lower. So one is the mistake for aluminium and another one is for argon. Is it clear, this question? The two elements which they are not shown correctly. The next is explained with reference to the structure and bonding why silicon has a high melting temperature. So why in terms of bonding and in terms of structure, why the silicon is having a high melting temperature. And it's of 3 marks. How you score all 3 marks here? First thing, you'll mention a silicon will have a giant covalent structure and it will have covalent bonds between the atoms. And we need lot of energy to break the bond. So how you score 3 marks? Number one, the structure, what kind of structure it has? It has a giant covalent structure. What kind of bonding is there? It has a covalent bond between the atoms. And we need lot of energy is needed, because why a substance will have a high melting or a boiling point? Because we need lot of energy is needed to increase, to break the bonds between the atoms. That's why we say it has a high melting. Is it clear, this one? So it's important. It is important that you learn the structure of the answer. Then aluminum has a greater electrical conductivity in period 3. Describe how metals conduct electricity. So explanation why metals are good conductor, metal conduct electricity. So what first you will explain the structure of a metal. A metal consists of a lattice of a positive ion and the delocalized electrons. And these electrons are free to move within the structure. That's why it can conduct electricity well. So metal consists of the lattice of positive ions and the free or the delocalized electrons. The second point, the electrons are free to move within the structures. So electrons are free to move within the structure. That's why metals are good conductor of electricity. Give a possible reason why aluminum has a high electrical conductivity than sodium. So what is the reason why the electrical conductivity of aluminum is much higher than that of sodium? Because aluminum loses 3 electrons, like it has more delocalized electron than sodium for per one atom. So aluminum loses more electrons per atom compared to sodium, and as it loses more electrons compared to sodium, so it has more electrons in the structure. That's why aluminum is better electrical conductor than sodium. Then aluminum is extracted by electrolysis of aluminum oxide in a liquid state. Draw a dot and cross diagram to show the bonding of aluminum oxide. Dot and cross diagram to show the bonding of aluminum oxide. So because metal and non-metal, so what kind of bonding they will have? They will have ionic bonding. So the structure of aluminum oxide, like the formula of aluminum oxide is Al2O3, because aluminum is +3 and oxygen is -2. So we have to draw 2 aluminum and we have to draw 3 oxygen. And aluminum, it will lose all the valence or the last shell electron. So each aluminum will get a +3 charge or 3+ charge. And for oxygen, we draw the